What if glass was actually a liquid? What if everything you believed about glass was wrong? For decades, rumors have claimed that glass is a supercooled liquid, silently flowing over centuries. Tales of old church windows thicker at the bottom seemed like proof. But is this really true? The truth is far more complex and fascinating. Glass is not a liquid, nor is it a true solid. It exists in a unique state of matter called an amorphous solid, a material that behaves like a solid but has a molecular structure closer to that of a frozen liquid. But what does this mean? The belief that glass is a liquid stems from its disordered molecular structure. Unlike crystalline solids like ice or quartz, which have perfectly ordered atomic patterns, glass has molecules that are randomly arranged, like a liquid, yet they don't move. In truth, glass is a material trapped between two states. It lacks the structural precision of a true solid, but its molecules are locked in place, frozen in chaotic patterns. While glass doesn't technically flow like a liquid, it does undergo incredibly slow atomic rearrangements over geologic timescales. At room temperature, this movement is so slow that it would take billions of years for a window pane to show any measurable change. The famous claim that old church windows are thicker at the bottom because the glass flowed downward over centuries? It's a myth. Those uneven panes were never symmetrical to begin with. Medieval glassblowing techniques made glass uneven, and builders often installed the thicker edge downward for better stability. While everyday glass appears stable, extreme conditions reveal its hidden nature. Glass under immense pressure behaves like a viscous fluid, deforming under stress over time. In volcanic environments, molten rock, essentially natural glass, cools rapidly into chaotic, glassy formations. This type of glass flows faster than ordinary glass, but still behaves more like a solid than a liquid. What if glass played a role in the future of space exploration? Researchers have discovered that glassy materials can resist intense cosmic radiation better than most metals. Spacecraft shields made of specially treated glass could provide long-term protection from solar radiation, preserving sensitive equipment, or even human life, on future missions to Mars and beyond. What if glass was Earth's ultimate time capsule? Unlike organic materials that decay or metals that rust, glass can endure for thousands, even millions, of years. Archaeologists have uncovered Roman glassware that's over 2,000 years old, still shimmering with only minor surface degradation. Glass may not be truly eternal, but its resistance to decay makes it one of the most enduring human-made materials in existence. What if glass could be stronger than steel? Tempered glass, created by rapidly cooling molten glass, develops extreme internal tension. This process gives tempered glass remarkable strength. It can resist impacts that would shatter ordinary glass instantly. Tempered glass is used in car windows, skyscrapers, and even bulletproof glass, demonstrating that this fragile-looking material can become astonishingly resilient with the right engineering. What if glass could transform the digital world? Modern fiber optic cables, made from ultra-pure glass, transmit data at the speed of light. These cables form the backbone of global internet communication, carrying billions of messages, videos, and conversations across continents in milliseconds. With ongoing research, scientists are exploring smart glass that can alter its opacity, creating self-shading windows that reduce energy costs and improve building efficiency. Imagine a world where glass is integrated with artificial intelligence. Researchers are developing glass materials capable of storing data in three-dimensional structures, turning windows and glass surfaces into complex information storage systems. Some believe that glass may one day replace silicon as the foundation for computing hardware, creating data drives that could hold vast amounts of information for thousands of years without degradation. So, is glass a liquid? Not quite. But it's also not a typical solid. It exists in a delicate state, an ordered chaos, where molecules are frozen in endless motion. Far from ordinary, glass is an extraordinary hybrid of states, a material that protects, endures, and even evolves with time. It's neither liquid nor solid, but something far stranger and far more powerful than we once believed.